Hello everyone, welcome to Mr. Schultz's Integrate 2 math class. Make sure you write the information in the top left and right hand corners. We're going to do our notes on 6-2, areas of regular polygons. Example 1, identify segments and angles in regular polygons. So in the figure, regular hexagon JKLMNP is inscribed by the circle R. Identify the circle, the radius, an apothem, and a central angle of the polygon. Then find the measure of the central angle. All right, let's pause. All right, so the center is R. R. The radius would be, we can say RL. And more specifically, we'd want to probably draw in and go, okay, line segment RL. Now the apothem is going to be that 90-degree angle straight, the point from the center to the side of that hexagon right there. So let's put that in. An apothem would be line segment RF. Okay, so the central angle of the polygon. Okay, well, let's take 2 points and with the vertices or the vertex of the center. So angle ARL. Now that's a little shorthand. Normally I like to do the drawing like this and go angle KRL, but shorthand's okay if you're typing it up. All right, so now the final thing it says is find the measure of the central angle. All right, so basically you're going to take the circle, how many degrees are in a circle, and then divide by how many sides. So for example, if we had a square, you divide, there's 4 sides, so 360 divided by 4 would be, what does each angle of a square be? 90 degrees. So we're going to take this 360 and divide it by 6 sides. And that would give us what? All right, that would give us 60 degrees. And there should only be one division bar right there. That's the angle of central angle right there. So yeah, the measure of each central angle is 60 degrees. All right, there we go. Next up, we want to go on to example 2, area of a regular polygon. Now we did kind of skip chapter 4, but we'll be going back to it maybe at the end of the semester. We'll see. So we didn't cover everything. So tangent of an angle is going to be the opposite over the adjacent. So hold up on that. All right, so I've set this up. So an octagon has 8 sides. So we're going to take 360 and we're going to divide it by 8. So if we divide 360 and divide by 8, we should get 45 degrees. Well, wait, there's more. That's the degrees of A, B, C right here. So what we're going to do is we're going to take that and go further. But before we go on, let's write down the area or the formula for the area of a regular polygon right here. All right, so here's the formula. The area of a regular polygon is equal to 1/2 of the apothem. That's this pink line, red line right there, going from straight down to the side, times the perimeter. So we have to figure out what the apothem is right here. So if we rewrite this, we'd get the area of 1/2. The apothem, well, the perimeter is going to be 8 sides. 8 times 4 is 32 centimeters. Half of 32 will be 16 times the apothem. So at the moment, what we have to do is we have to figure out how long is that apothem, and then we'll have our area. So basically we have to use some trigonometry to figure out, all right, how do we figure out BD right here. How do we figure out BD? So what's that equal to? All right, well, tangent of an angle is the opposite side. So we know what this is. So we already cut this in half. This is a perpendicular bisector right here. So we just cut it in half. So half of 45 would be 22.5 degrees. All right, so the tangent of 22.5 degrees is equal to the opposite side. So if we're right here, we want the opposite side. And wait, if this is the perpendicular bisector, half of 4 would be 2. 2 over the apothem, the adjacent side. So here's the hypotenuse, here's the opposite side right here, here's the adjacent. Adjacent is like next door. So let's say this is A because it's the apothem. All right, well, using our property of multiplication, the multiplication property of equality, we can multiply by A on both sides. Get it out of the basement. We don't like it in the basement. And so we will get A times the tangent of 22.5 degrees would be equal to 2. So at this moment, I'm going to figure out what the tangent of 22.5 degrees is. But wait, there's more. Actually, we don't need to do that. What we're going to do is we're going to just isolate for A. So what we're going to do is we're going to divide by the tangent of 22.5 degrees on both sides. And then we can simply, substitute 2 divided by the tangent of 22.5 degrees and substitute for this. So we get the area would be equal to 16 times 2 divided by the tangent of 22.5 degrees. And at this point, that's not the answer. At this point, I'd be like, all right, can we do anything? No, you're going to have to use your calculator and do the tangent of 22.5 degrees and figure out what that is. After doing that, we would get, and we do all the multiplication, we get the area is around 77.25 centimeters cubed. Or no, squared, sorry. 77.25 square centimeters. All right, let's go on. All right, so we have 2 more examples. Let's see if we can bust these out. So it says find the area of a composite figure by adding. All right, well, I know that this is equal to 9 centimeters right here. This should have been right here. It got moved when I was, for some reason, it got moved. So this is 9 centimeters right here. So I know that the area of this guy would be 9 centimeters times 9 centimeters. The area of the square is 9 centimeters squared. And then I'm going to add this regular polygon right here, but hey, I can leave that off. Let's call this the area of the reg. And we'll come back to you. Plus, okay, this is a trapezoid. It's the area that is 1/2 base 1. So base 1 is 9 centimeters plus 15 centimeters, and then times the height of it, which would be 19 centimeters. So 9 plus 15 would be 24, and then 24, half of 24 is 12, and then 12 times 19 is 228. So this is equal to 228 centimeters squared. And this one would be 81 centimeters squared. and plus whatever this is. Well, now what we have to do is we have to figure out what that is. So if I add this, I get 309. 309 centimeters squared plus the middle part right here. Well, let's figure out what the middle part is. So basically what we could do is we have to figure out what the apothem is. So we can take this right here, figure out what the apothem, and remember the area of a regular polygon is equal to 1/2 of the apothem times the perimeter. So the perimeter of this is 9, 1, 2, 3, 4, 5, 6. 9 times 6 is 54 centimeters. Well, now and then we have this half right here. And then we have the apothem. We have to figure out what is the apothem. 27 centimeters. Well, why don't we do it? So the apothem, going from previously, if we have this right here, we understand that the central angle will be 360 divided by 6, which would be 60. So if we do a perpendicular bisector right here, we create a right triangle, and this is now 30 degrees right here. Now, I know that there's a trick with 30 degrees. So the trick is that in a 30-degree angle, you're going to have the opposite. The apothem will be the opposite times radical 3. So I don't even have to do anything with tangent. I know that in a 30-degree, 30, 60, 90 triangle, because that's 30, this has to be 60, it's going to be 4.5 times radical 3. So I know that the apothem is 4.5 radical 3 centimeters times that. So if I multiply these right here, I should get 210, I think, 210.4 centimeters squared. And if I add those together, I get 519.4 centimeters squared. So the trick with composite figures is you break it up into its parts, and then you solve each part, and then put it back together, and you should be good. All right, guys, let's go on to example 4. Find the area of a composite figure by subtracting. Okay. So first off, what we can do is we can figure out the area of this and understand we're going to subtract the triangle. So the area of the trapezoid minus the area of the missing triangle right here. Now, we have to figure out what the triangle is, but we can figure out what the trapezoid is right now. So the area of a trapezoid is 1/2 the height, which is 1 plus, the triangle. So we have to do it first. So let's erase it. We'll come back to it in just a second. All right, so let's take this triangle. I like to flip it up. So I know that this is going to be, so it is an isosceles triangle, and now since I've cut it in half, we've created a Pythagorean, or a right triangle, in order for us to be able to use the Pythagorean theorem. So I can figure out what this height is by doing a squared plus b squared is equal to c squared. So I know that this is my c squared. I have 36 meters squared is equal to, well, I'm going to say that 1 meter squared, because 1 times 1 is 1, plus b squared. So if I subtract 1 meter squared on both sides, I'll get 35 meters squared. Well, how about this? Just remember, hey, what's 36 mushrooms minus 1 mushroom? It's 35 mushrooms. So now we have b squared the height is equal to 35 meters squared. Wait, that's not right. The height squared is equal to 35 meters squared. So the opposite of squaring would be square root. So we get b will equal the square root of 35. We can leave it right there. And technically it's, meters. Alright, so now what we can do is we can find the area of the triangle. The area of the triangle is 1/2 the base, which is 2, times the height, which is radical 35. Oh, 2 meters. So the area of the triangle is equal to, half of 2 is 1, and 1 times 35 is, radical 35 meters. That's the area of the triangle. Okay, well, now we find the area of the trapezoid. So the trapezoid is equal to 1/2 base 1, which is 5 plus 5 plus 2, 12 meters, plus 8 meters times its height, which would be 1 plus whatever that is. Multiplying that. All right, well, going on, this would be 20 meters, and half of 20 meters, so half, well, let's write it. So half of 20 meters would be 10 meters, and then this is an area, so this would be 1 plus radical 35 meters. I don't even know what it is, but it's something meters. Now we're going to use the distributive property and understand, hey, we're going to multiply this and this and this and this. So we'd get 10 plus radical 30, 10 radical 30, 35 meters. And remember, this is the area of the trapezoid, and we have to take out the area of the triangle. So we're going to take out this radical 35 meters right here. And if we did that, 10 bacons minus a bacon would be 9 bacons. So we'd have like 10 plus 9 radical 35, and then all that in meters. But if we actually use our calculators to figure it out, we get, the area would be around 63.2 meters. Oop, forgot it. Meters times meters. What's meters times meters? It's meters squared. Just remember, when you're doing these, you have to make sure that you use the correct units of measurement. Bye, guys. Thank you for taking time for this extremely long one. I'll see you in class. Bye.